All right, so finishing up week 2 here, looking at section 5, right angle trigonometry. And it turns out this is a review of stuff we've already done. So there's not too much new here, except maybe some cute story problems. So back to the unit circle for a second, or any circle for that matter. We played with the idea for a while that we measure an angle from the positive x-axis counterclockwise, and we move around that way. So let's say that's the radius I'm going to choose. That radius swept an angle. Standard form of that angle, again, is from the positive x-axis counterclockwise to wherever I end up. So that's my angle theta. We then played with the idea that we can drop a perpendicular to the closest part of the x-axis. So that would be right over here. And that forms this right triangle. This angle over here, let's do that in a different color. Oops, let me get my pen out. Not my line tool. This angle right here in green is my reference angle, and let's say I'm going to call that T. So I've now taken my standard angle, which is you can see an obtuse angle here. It's greater than 90 degrees, greater than pi over 2. And then I drew my reference angle here, which is to the closest part of the x-axis, and that perpendicular gives me a right triangle. So we've been using right triangles all along. So the idea of right triangle trigonometry somehow being different than the trigonometry we've been doing is not true. It's the same thing. So I now have this triangle right here, and on the circle, that triangle leads to this point up here, and that point has a y value and an x value. Right? And on the triangle I drew, there's my y value, and right here is my x value. And we know that in that triangle there, let's just redraw that out here. Angle is T this time. That is right, that is Y, that is X, that is R. We know that based on our trig so far that we have this function called the cosine function that takes that angle and returns a ratio that is the x value divided by the radius. And we know that the sine function takes that angle T and is going to turn it into the y value over the radius. And we have another special one called the tangent, and those are really the most important three. The other ones are just kind of useful sometimes. That is y divided by x. And in this case right here, since I've kind of separated myself from the circle, I'm not really worried about the quadrants and the sign. So I'm just going to say everything here is a positive value, no big deal. So that's kind of the difference between a right angle trigonometry and circular trigonometry. We kind of ignore signs and we ignore the direction of the angle, but it turns out the first way we did it is really the more powerful way. This is kind of like the old school way to do it, but they usually add it as a separate section in the book. And really at this point, it's just review. So that's right angle trigonometry right there. That's what's in this section, along with a few new story problems. And so we're just going to play around. Given information about one trig function, can we then find out information about another trig function? So quick example of that. Let's pick a reference angle. And in that picture right there, let's suppose I was trying to get, what do you think the closest special angle is to the place I'm at right here? So I'm looking at this and thinking, well, it looks like that is around 30 degrees or pi over 6 off of that right there. I know that an angle of pi puts me on the negative x-axis here. So if I back up pi over 6 from that, that's going to give me 5 pi over 6. So now I'm going to claim that my theta, I meant that to be 5 pi over 6. The reference angle T is going to be then just pi over 6, right? That angle off of the closest part of the x-axis. So this one is what we call the standard version of the angle. Remember, and this one we call the reference angle. So in right angle trigonometry, you pretty much just work with reference angles, is the big difference. And then I have to remember some things about that. So if the radius was 1, then the x value there, so if r was 1, then that point right there, y would be about a half, be exactly a half, and x would be in that quadrant, it would be negative square root of 3 over 2. But when we look at right angle trigonometry, we kind of ditch the sign. So I'm just going to call it the square root of 3 over 2. So then for this particular angle here, I can tell you what each of those are. So for example, the cosine we should know of 5 pi over 6. Oh no, I'm using the reference angle, I lied. Just pi over 6. That's going to be the x value divided by the radius. So square root of 3 over 2 over 1, which is just the square root of 3 over 2. And then the sine of that reference angle is going to be the y value over the radius. So 1/2 over 1 is just 1/2. And then the tangent of that angle. And then these are values I think you should just have memorized at this point. If you don't, then you need to rewrite that version of the first quarter of the circle, first quadrant of the circle until you have it memorized. It's going to be y over x. So that would be 1/2 divided by the square root of 3 over 2. Halves divide out, so that'd be 1 over the square root of 3. And I prefer this answer because I got it first. But if you rationalize the denominator, this is also the square root of 3 over 3. You'll sometimes see that version out there. So that's part 1 of right angle trigonometry.